In the late summer of 1977, two small points of light rose on pillars of fire from Cape Canaveral. They were not bound for orbit. They were not bound for a planet. They were bound for forever. NASA called them Voyager 1 and Voyager 2, twin explorers cast into the deep, their mission, to reveal the hidden faces of the giant planets and then to keep going. They would be our messengers on the cosmic wind, carrying whispers of Earth into a realm no human hand could ever reach. The 1970s were a strange and wondrous moment. Our feet had touched the moon. Our eyes had followed the pioneers, 10 and 11, as they pierced the asteroid belt and dared to meet Jupiter and Saturn up close. But the Voyagers were different. They were not just scouts. They were archivists, scientists, and storytellers. They carried instruments to see, to listen, to taste the magnetic seas and the particle storms. And deep within their frames, each carried a golden record, a time capsule of our music, our voices, our images. A declaration that we once existed here on a small blue world in the light of an ordinary star. The launch order was a little misleading. Voyager 2 departed first on August 20th, 1977.
1. We have ignition and we have liftoff. We have liftoff of the Titan Centaur carrying the first of two Voyager spacecraft to extend man's senses farther into the solar system than ever before.
Voyager 1 followed on September 5th.
4, 3, 2, 1. MDS, we have ignition, we have a liftoff.
Roll program is in on time. Vehicle response is normal.
TVC bus voltage looks good. Tank pressures look good.
But their trajectories were designed so that Voyager 1 would overtake its sibling, reaching Jupiter first. Both would ride a rare alignment of the outer planets, an alignment that comes only once every 176 years. By swinging around one world, they could steal a little momentum and be flung toward the next, surfing a chain of gravity assists that would save decades of travel time. In the years that followed, they would change everything we thought we knew about the gas giants. They would discover moons with erupting volcanoes, worlds of fractured ice and hidden oceans, storms larger than Earth itself. They would map faint, ghostly rings and measure magnetic fields that wrap their planets like invisible armor. But this was not only a mission of science, it was a mission of perspective, because once the planetary encounters were done, the Voyagers would keep moving, past the orbits of Neptune and Pluto, past the edge of the Sun's great magnetic bubble, the heliosphere, into the black gulf between the stars. For the first time, we would have eyes and ears in interstellar space. Even now, more than 4 decades later, they are still talking to us. The radio signal is 1 billion times fainter than a whisper. It leaves each spacecraft at the speed of light, travels for nearly a full day across the darkness, and is caught by one of Earth's great deep space antennas, Goldstone, Madrid, or Canberra. Through those antennas, through that fragile thread of light, the Voyagers are still telling us what they find. And here is where I want to welcome you. Because this is Wormhole to Cosmos, and tonight you and I will follow those faint signals. We will walk in the shadows of Jupiter and Saturn, sail past Uranus and Neptune, and step with the Voyagers into the silent sea beyond the sun's reach. We will meet their predecessors, the pioneers. We will glimpse their successors like new horizons, and see how each carries our story farther into the dark. This is not just a mission report. This is the tale of our first true emissaries to the galaxy, and their journey has only just begun. The 1970s were a turning point. The moon landings were behind us, the space race had cooled, and NASA needed a new vision. Out of that search came an idea as bold as any Apollo mission, to take advantage of a rare planetary alignment that happens only once every 176 years. This cosmic arrangement placed Jupiter, Saturn, Uranus, and Neptune in such positions that a single spacecraft using gravity assists could visit them one after another. A grand tour of the outer solar system. Originally, the plan called for 4 spacecraft, but budget cuts reduced it to 2, Voyager 1 and Voyager 2. Even so, their objectives were ambitious: explore Jupiter and Saturn, and if the spacecraft survived, aim for the farther worlds. Officially, they were designed to last only 5 years. Few could imagine they would still be operating nearly half a century later. Building them was no simple task. Each Voyager carried a suite of 10 scientific instruments, cameras capable of capturing distant worlds in detail never seen before, and radio systems strong enough to beam signals across billions of miles. They were powered by radioisotope thermoelectric generators, tiny nuclear batteries that could keep their instruments alive far beyond solar power's reach. At the helm of this daring project was John Cassani, Voyager's first project manager. Known as a meticulous engineer and a tough but visionary leader, Cassani guided his team through countless challenges in design, testing, and integration. He was also the first to imagine attaching a message from humanity to the spacecraft, an idea that would become the famous Golden Record. Cassani often reminded his team that space exploration demanded resilience. You can do 1,000 things right, but if you don't do everything right, it'll come back and bite you. That toughness would define Voyager, shaping a spacecraft ready to survive the unknown. On launch pads in Florida in 1977, 2 identical spacecraft waited. Ahead of them lay Jupiter's massive storms, Saturn's mysterious rings, and, if fortune held, encounters with the most distant planets ever visited. The grand tour was about to begin. When Voyager 1 swept past Jupiter in March 1979, humanity witnessed a world we thought we knew transformed into something utterly alien. From Earth, Jupiter was always a swirling ball of bands and storms, its great red spot an enduring mystery. But the Voyagers revealed a dynamic, restless world, brimming with detail beyond imagination. Nearly 19,000 images streamed back from Voyager 1, soon joined by over 33,000 from Voyager 2. And what they showed, rewrote textbooks. The greatest surprise erupted from Jupiter's moon, Io. Against all expectations, Voyager 1's cameras caught towering volcanic plumes shooting hundreds of kilometers into space, the first active volcanoes ever seen beyond Earth. This discovery alone redefined what moons could be, not frozen, dead spheres, but worlds alive with heat and change. Jupiter itself astonished as well. The great red spot, once thought a static mark, revealed itself as a massive storm system, with winds howling at hundreds of kilometers per hour, more dynamic than anyone imagined. Lightning flashes were recorded in its atmosphere, evidence of immense energy churning beneath the clouds. Then came Saturn. In late 1980 and summer 1981, the 2 Voyagers delivered close-ups of the jewel of the solar system. Saturn's rings, from Earth seen as delicate bands, became revealed as complex structures filled with countless ringlets and mysterious gaps sculpted by the pull of tiny moons. Saturn's largest moon, Triton, appeared veiled in a thick orange haze, a world hiding secrets we would not unlock until decades later. The encounters with Jupiter and Saturn marked a turning point. The spacecraft had achieved their official goals, but Voyager 2 in particular had a path open before it that no probe had ever taken, onward to Uranus and Neptune, the 2 most distant giants. The Grand Tour alignment had offered humanity a once-in-a-lifetime opportunity, and the Voyagers were just beginning to seize it. Voyager 2, the only spacecraft to continue beyond Saturn, ventured into territory no human eye had ever seen. In January 24, 1986, it reached Uranus, a planet so distant that before this encounter it was little more than a fuzzy blue-green dot in telescopes. What Voyager revealed astonished scientists. Uranus was tipped dramatically on its side, rolling through space like a ball rather than spinning like other planets. Its magnetic field was equally strange, not aligned with its axis, but tilted and offset, producing an environment unlike any we had studied before. 11 new moons were discovered, each a frozen, cratered world, along with dark, thin rings barely visible against the planet's pale glow. Uranus, once thought dull and featureless, became a world of mysteries. 3 years later, in August 1989, Voyager 2 reached Neptune, the most distant planet it would ever visit. The spacecraft's cameras revealed a deep blue world with raging storms, including the Great Dark Spot, a massive tempest as large as Earth. Neptune's winds turned out to be the fastest in the solar system, howling at over 1,000 miles per hour. But the true marvel was Triton, Neptune's largest moon. Against expectation, this frozen world proved geologically active. Voyager 2 caught geysers of nitrogen gas erupting from beneath its icy crust, a cousin to the volcanic plumes of Io, but in a far colder realm. Triton's surface was scarred with ridges and plains shaped by forces still not fully understood, marking it as one of the most unusual bodies in the solar system. With Neptune behind it, Voyager 2 had completed the most ambitious planetary survey ever attempted. 4 giant planets, dozens of moons, and a trove of discoveries that reshaped our view of the solar system. From this point onward, both Voyagers would head into uncharted space, past the realm of the planets toward the invisible boundary where the sun's influence gives way to the galaxy beyond. With the planetary encounters complete, the Voyagers turned toward their ultimate frontier, interstellar space. Though launched to explore Jupiter and Saturn, they were now on trajectories that would carry them beyond the sun's protective bubble, the heliosphere. The heliosphere is a vast envelope of charged particles and magnetic fields pushed outward by the solar wind. Inside, we are sheltered by the sun's influence, but at its outer edge lies the heliopause, the invisible boundary where the solar wind collides with the interstellar medium, the gas, dust, and radiation that fills the galaxy. Crossing this threshold would mean stepping outside the sun's domain, into true interstellar space. Voyager 1 reached that boundary in 2012, more than 11 billion miles from Earth. Instruments on board detected a sudden rise in cosmic rays from deep space and a disappearance of the familiar solar wind. 6 years later, in 2018, Voyager 2 followed, carrying one instrument its twin had lost, the plasma science experiment. With it, Voyager 2 provided the first direct measurements of interstellar plasma, confirming the long-anticipated passage. No other spacecraft has achieved this. The Voyagers remain our only direct witnesses to the environment between the stars, where the sun is no longer the dominant force. Even now, they continue sending back data that is shaping our understanding of the galaxy's structure, magnetic fields, and the nature of cosmic radiation. Yet, interstellar exploration comes at a cost. With each passing year, their power supply dwindles and their instruments grow fewer. Keeping them alive requires ingenuity and patience, as engineers fight to preserve humanity's farthest outposts in space. By the time the Voyagers reached interstellar space, they were already decades past their design life. Originally expected to last just 5 years, the spacecraft are now held together by persistence, ingenuity, and the skill of the engineers who continue to nurse them across the void. Their greatest challenge is power. Each craft is fueled by a radioisotope thermoelectric generator, RTG, which slowly loses output as its plutonium decays. Every year, the Voyagers shed about 4 watts, forcing mission control to shut down heaters and non-essential systems to keep the science instruments alive. Some instruments now operate in extreme cold, well below what engineers once thought survivable. On Valentine's Day 1990, Voyager 1 turned its camera back toward home one final time. From more than 4 billion miles away, it captured a mosaic of our solar system, the family portrait. Within that sweep of faint planets, Earth appeared as a single pixel, a pale speck of blue suspended in a shaft of scattered sunlight. That fragile dot became one of the most iconic images ever taken. It wasn't part of the original mission plan. In fact, the idea had been rejected for years due to concerns about pointing the cameras too close to the sun. But persistence, particularly from Carl Sagan, finally convinced mission leaders. The result was an image that transcended science and entered philosophy. Sagan described Earth in that picture as a mote of dust suspended in a sunbeam. On that pixel, he reminded us, lived everyone who has ever lived, every king and peasant, every mother and child, every explorer and every coward. Against the vastness of the cosmos, Earth is both vanishingly small and infinitely precious. The pale blue dot altered how humanity sees itself. It reinforced the urgency of protecting our only home and underscored the unity of our shared existence. No borders are visible from such distance, no divisions except those we create. The Voyagers were built to explore the planets, but in that last glance back, Voyager 1 helped us discover something even greater: perspective. After taking those final images, Voyager 1's cameras were permanently shut down to save power. It would never take another picture, yet that last glimpse of our fragile world adrift in the dark ensured the Voyager's place not just in science, but in culture, philosophy, and the human heart. Among all of Voyager's instruments, cameras, and sensors, perhaps its most enduring cargo is not meant for science at all, but for communication. A message carried across the stars for any who might someday find it. This is the Golden Record. The idea came from Carl Sagan and his team at Cornell University. They imagined Voyager not only as a spacecraft, but as an ambassador, carrying greetings from Earth long after its systems fall silent. The record would be a time capsule of humanity, cast into the cosmic ocean, waiting to be discovered. But how do you speak across light years to beings who may not share our language, our senses, even our way of thinking? The answer lies in the record's cover: a map, a manual, and a universal key to decoding its contents. In the upper left, a simple drawing of a record and stylus, with binary numbers etched around it. These numbers tell the finder how fast to spin the record: one rotation every 3.6 seconds. That number itself is written in the language of the universe, the transition time of a hydrogen atom, the most common element in existence. It is a clock no civilization could misunderstand. Just below, another diagram shows how long the record will play, about an hour per side. To the right, waveforms illustrate how the signals will look, lines of binary code that build into images. The instructions explain that pictures are drawn as vertical lines, 512 of them, just like an old television set. The very first image is a circle, a test, so the receiver knows they've decoded it correctly. In the lower left is a pulsar map. 14 beams, each marked with binary numbers, define the spin rate of pulsars scattered through our galaxy. Together they form a unique galactic fingerprint. If someone finds Voyager, they could trace these lines back and know exactly where and when this message came from. And finally, at the bottom right, the hydrogen atom once again. Two states of its proton and electron, a reminder that the time it takes to change between them is the universal unit used in every diagram. It is the foundation upon which this interstellar language is built. The record itself is made of gold-plated copper, designed to last 1 billion years. Its cover includes a trace of uranium-238, slowly decaying, a built-in clock, so any finder can know how much time has passed since launch. And scratched by hand, just 4 words: to the makers of music, all worlds, all times. But what does it contain? When the stylus touches its grooves, the story of Earth begins. Greetings in 55 languages, sounds of our world, wind and surf, birdsong, a mother's kiss, the beating of a human heart, music from across cultures and centuries, from Bach and Beethoven to Navajo chants, from Senegalese drums to Chuck Berry's Johnny B. Good. Images of Earth, our landscapes, our cities, our science, our children. It is not everything, but it is enough to say, we were here. Carl Sagan called it a bottle cast into the cosmic ocean. He knew the odds were slim that anyone would ever find it, but he also knew the message was not only for them, it was for us. A reminder that in the vastness of space on a pale blue dot, we are one people, sharing one fragile home. And so the Voyagers travel on, carrying this golden song through interstellar night. Long after Earth has changed, long after our cities fade and our voices quiet, they will still be moving outward, still whispering across the dark. This is who we were. This is where we came from. And with that, our story of Voyager draws to a close. Nearly 5 decades after launch, these spacecraft still journey beyond the reach of the sun, carrying science, memory, and hope. They are more than machines. They are symbols of endurance, of curiosity, of the human desire to explore without end. Thank you truly for spending your time with us here on Wormhole to Cosmos. More incredible voyages await. We'll be exploring Pioneer, Cassini, New Horizons, and the rest of this family of daring spacecraft in future films. And before we go, I'd like to share something personal. On a trip to Northern Ontario, I met a remarkable young man named Jack, only 14 years old yet already deeply passionate about astronomy and astrophotography. Meeting him reminded me that the future of discovery rests in the hands of young dreamers like him. Jack, and countless others like him, will be the ones to carry our curiosity forward, to ask new questions, to light the path into the cosmos. So to all the young minds watching, follow that spark, chase the wonder. If you love space, science, or the stars, pursue it. The universe is waiting for you. Before we close, I have a question for you. If you were asked to add one sound, one piece of music, or one image to a new golden record, what would it be? Leave your thoughts in the comments. I'd love to hear what you would send to the stars. Thank you for watching and for being part of this journey with us. Please like and subscribe. It truly helps us continue to bring you these stories of the cosmos. And as always, remember, the universe is vast, mysterious, and full of wonders waiting to be explored. Stay curious, keep looking up, and until next time, keep your eyes on the stars.